Oh my god. It's perfect.
That's exactly how I planned it.
That's insane. We're gonna be flying in this.
How much wider is this gonna be than a four-wheeler? 56 inches wide versus 40 inches wide. Okay guys, we are back on the Power Wheels and it looks freaking fantastic. We redid the upper frame rails. We used to have square tube here that was rusted from like 2 years ago when I was working on it. To get these bends in it, I made pie cuts. It didn't look great, it was weak. And now we've got round tube in there that we got with the tubing bender. It makes it look way nicer. Also, we finished out the rear frame for the upper and lower mounts of the A-arms. We have our spool in place and just got some sweet rear shocks. These are off of a Polaris 900 XP. They're front shocks on it. So I think they will be soft enough for our long travel rear suspension. They got a 600 preload adjustment. We're gonna start working on the A-arms today. This is gonna mount in here like that, I think, because that's just gonna look sick. That's the plan for today, doing the A-arms. Yeah, I'm super excited. Okay, so here's what I did. I took a tube and I tack welded a nut in on either end. That way I can place these pivot points onto the rail and I know they are aligned with each other. This is gonna sit somewhere on there like that. This is gonna sit down here like this as well. Really don't have any idea of how to build A-arms with tube bending, so this will be my first time trying to figure that out. The inner diameter is the same as the outer and then you can just weld them up nice. Eyeball it, I guess. We want this to come straight and then bend into it. So you see it doesn't twist too much at the bend.
Yeah.
Not bad.
Think it looks great.
Yeah, it's close to 90. Oh, God. Sometimes you're just born genetically superior.
Great job, babe.
Wow.
That fits perfectly.
The problem is I'm not going to be able to perfectly replicate it for the other side. Okay, that's much better.
And you can tell this is a right angle. It actually looks perfect right now.
Yeah, it's almost exactly dead on. This piece is too short. Well, it's actually not terrible, but it's further back longer than I want it to be. How cool these things look?
They are very cool.
Gonna sit like that, I think.
When is it fighting you? When you're pulling up?
At the extremes. This plate right here, this is the line that is going through the center of the wheel. So if the wheel was on it right now, the wheel would be like this. Right now, like this can hold straight up like that. It can still spin, which is good. And as it goes through the arc, I want to make sure that this stays parallel, which it is, it's doing good, but
it's fighting to stay there.
It's fighting to stay there, which, you know, the purpose of the upper arm is to make it so that it stays straight. So this is called plunge. See how the axle's going in and out?
Yeah.
Luckily, it seems like that is kind of making up for the suspension geometry right now. I'm holding it from here. It feels pretty good. I can undo this bolt and these can get lengthened if I need them to. What we're gonna do is we're gonna make sure that we build this upper one a little bit shallower. Part of the reason that's a problem, the axle is pivoting in here. This pivot point's out here. This pivot should be in line with this pivot, which they're not. We'll see what it's doing once we build the upper arms, and we'll make a determination if we need to readjust where these are pivoting. Okay. I can put it back in and try to start bending here. right?
Babe, that looks awesome. It's curved exactly like the other one.
Actually, I think that looks really cool. I think it looks really cool
awesome.
like that.
Mm-hmm. I had my eyes open that whole time.
Did you?
No, I'm kidding. I'm kidding.
Look at how positive it gets.
Up at the top here?
Yes. I mean, we're not going to be driving at that, but it's still not a design feature that I would like. When you look down these A-arms, they're not in the same plane. They're like this. This isn't flat across to this, and this isn't flat across to that. It's just a cosmetic thing. Here's the thing, this is not moving badly at all. I'm going to grind this guy and swivel this down under and see if that changes anything real quick.
Babe,
okay?
this looks excellent. Like, I'm not even kidding. This looks like it was made in a factory.
Thank you. That's so sweet.
Better?
I think so. Before, these tabs were rotated up higher. They rotated more straight out. Now I move them underneath a little bit. It's definitely moving better. Okay, we don't have any binding. It's excellent. That's the thing I don't like. That's full droop, and right now the tension inside this system is keeping it from going lower. You don't want the suspension geometry itself to cause tension within the framework. That will create excess wear. That might just be the bottom of the axle.
I'm gonna try lifting it. That's insane.
That is absolutely ridiculous.
That is insane.
Those blocks are... That is 11 inches of suspension travel.
Great job, baby.
Thank you. I was getting binding primarily because the top was a little bit too short. So instead of cutting and making all new A-arms, I just undid the heim joints a little bit, which is the whole reason you use heim joints. Now there's no binding at all at the top or the bottom. That's perfect. Look at that. I accidentally built this side better. It's not finished yet because I still need to put this one on. But the alignment's a little better. So, see how much significantly higher this goes?
Oh, yeah. And
So
it looks easier, too.
That's what I was talking about with the internal binding versus on this side. I can try to lengthen these heim joints, the bottom and the top. The biggest thing is, you know, any travel where the bottom of the tire would be above the frame is pointless. But you want to get as much droop out of the suspension as possible. And right now it's binding because this isn't long enough and these aren't really long enough either. These arms are just a little bit longer. There we go. Pretty spot on. Check. I lengthened these heim joints out. You can see it's got some serious negative camber at the bottom, and you know we've got a crazy amount of travel now. So now we've got the full range of motion on this side, as well as the full range of motion on this side. Now I'm doing some CAD, cardboard design, and I'm designing the upper shock mounts for the shocks. So there'll be two of them, they'll sit on either side, and we'll have a metal pipe going between them for support. But I started out with a very extravagant one, as you can see from my frustration. It didn't work. Because I gotta make it fit underneath the body. I cut it out like 6 times, and then I tried to use the razor and it just destroyed it. Anyway, this is gonna sit on here like that, and it was gonna come, and then you were gonna be able to adjust the positioning of the shock. What I realized is when this is down here, this is gonna run into the plastic fender, and so it needs to be as close as it possibly can to the body. So we just got all 4 of these cut out, and I'm gonna tack them together, and then we'll drill a pilot hole through them. So I just finished tack welding these 4 together, cut them out. They're pretty bang on. So I'm just gonna mark up. All right, so we got all these bad boys drilled and mill scale taken off of them. So we're gonna put these on here. So now I also cut and notched this pipe. So this pipe is gonna sit here to grab the second one. It's nice and flat. Pretty much got that gap now.
Mm-hmm.
It is time to see this thing under its own weight. We have finish welded the tops and the bottoms, so hopefully it doesn't break. And then I've got some beefier tacks on this side. That side's fully welded with my TIG welder, so that side shouldn't break, but we'll see what happens once I start bouncing on it. Oh, that is so stiff.
Oh.
Uh-oh. Should not. What we can do is loosen up this preload on these springs. Alright, let's see it. I mean, they're still pretty stiff, but
I think it looks great. Like, you just need to loosen the shocks, you think? Like,
yeah,
more?
Yeah, so the more compressed this spring is, the stronger it is. So when it starts out being compressed an inch more, it's going to give you more resistance when you hit a bump. So it's called preload. So this will, the further up the spring is, the less preload the system has.